Welcome to the video for Unit 6, Lesson 12, where we're going to be exploring the interior angles of a polygon. Now, we've been dealing with quadrilaterals for a lot of this unit, but now we're introduced to this new word of polygon. So what a polygon is, it's just a figure with 3 or more sides. And we have to familiarize ourselves with the classification of these figures because their name can tell us how many sides that we are working with. So I'm sure you guys have seen pentagon and hexagon before, probably even octagon as well. But this table here has the number of sides along with the name or the classification of the polygon. So 3 sides is a triangle, going up to 8 sides is an octagon, 10 sides is a decagon, and 12 sides is a dodecagon. But typically, if it's large, like let's say a polygon has 37 sides, or something like that, then we might call it like a 37-gon, right? So the number of sides in this unit is typically going to be denoted by the letter n. So n always represents number of sides. So if it's a really large number, it might just be called an n-gon. So a 37-gon or a 50-gon, right? That number right before the gon tells you how many sides it has. And knowing how many sides a polygon has is going to be really, really important. So sometimes the regents will give you a name, like it'll say, hey, in a dodecagon, right? And you have to know, obviously, that a dodecagon, you have to be able to tell that it has 12 sides. So this table is going to be something you're going to have to remember. Now, we have 2 types of polygons. We have a regular polygon, and we have an irregular polygon. So in a regular polygon, this is a figure where all sides and angles are congruent. So if you take a look below, we have 2 hexagons. Now remember, if you remember from the table, hexagon was 6 sides, right? So in a regular hexagon, this is probably the image that you visualize when you think of a hexagon. That's where all 6 sides and all 6 angles are congruent. But guess what? This image over here is also a hexagon. Now, it may not look like a hexagon at all, but if you count the number of sides, we have 1, 2, 3, 4, 5, 6. Well, yeah, then by definition, it is a hexagon. But in an irregular polygon, right, none of these sides or angles need to be congruent. Like some of them can be, but it could be the case where all of your sides are different measures and all of your angles are different measures as well. So just be mindful, if it says regular, you know that all sides and angles are the same. Now, here's another example where we have a pentagon. Now remember, pentagon has 5 sides. So our regular pentagon, again, is probably the typical one that you see when you visualize a pentagon. All 5 sides and all 5 angles are the same. This is an irregular pentagon, again, where all of your sides can be of different lengths and all of your angles can be different as well. Now, we're going to be, in these next 2 lessons, talking about the measure of different angles. In this lesson, we're talking about the measure of interior angles of a polygon. And all of this comes from our prior knowledge of the sum of angles in a triangle. So we know our prior knowledge is that if we add up all 3 angles in a triangle, that we get 180 degrees. And that is going to help us with our discoveries today. So the sum of interior angles depends on the number of triangles that can be created by connecting vertices of the shape. So let's do it with a quadrilateral. We already know that the sum of interior angles is 360, but let's just test this. So if I choose to start at D, I can only really create this triangle, right? Like when you're making your triangles, you're choosing one vertex and all of your segments are going to come out from that vertex. So right now I can only create 2 triangles. So if I do 180 times 2, that gives me the entire sum is going to be 360. Now we know that, but it can be helpful for more complex objects. So let's pick this, how many, 1, 2, 3, 4, 5. This is a pentagon. So I'm going to choose this vertex, right? Now my first triangle I can create by connecting this to B, that would be 1 triangle. Another triangle going from D to A. And that is really it. So right here I see 3 triangles. So if I do 180 times 3, I don't have a calculator out right now. I'll get one. That is 540 degrees. So that means in a pentagon, I know that when I add up all 5 of these angles, whether it's regular or irregular, I know I'm always going to get 540. Now this is going to be a hexagon with 6 sides, and the pentagon has 5, obviously. So if I'm going to start at this vertex, right, I can make 1 triangle here, 1 triangle here, and 1 triangle there. So this is 4 triangles that are created. So here we do 180 times 4. and that would give us 720 degrees. So in any hexagon, regular or irregular, I know my sum of interior angles is going to be 720. So I know I put what looks like regular polygons in these images, but again, this can be true for irregular as well. And then lastly, I believe this is an octagon. So we have 8 sides, or I'm going to say n equals 8, n equals 6, n equals 5, and n equals 4, just to get us in that habit of using n. So again, I start from here. My first triangle goes here, my second triangle. But I'm gonna just make a prediction. You know what? Because if we take a look at the number of sides and the number of triangles that were created, like for a pentagon, there are 5 sides, but 3 triangles were created. In a hexagon, there were 6 sides, but 4 triangles created. So I'm gonna predict that the number of triangles is 6. Let's take a look. So I can connect here, and I can connect here. Let's count those. We have 1, 2, 3, 4, 5, 6. Look at that. Look at that. So we do 180 times 6, and that is going to give us 1,080 degrees. And again, remember, sum of interior angles, this is for regular or irregular. And again, the sum of interior angles clearly depends on the number of sides that you have and the number of triangles that can be created, right? So let's say we had a shape with, let's say on the side, let's say we had, the polygon had 46 sides. Using our pattern, we can kind of predict that there are going to be 44 triangles. So we'll be able to do 44 times 180, and that would give us a really, really big number. So these are the two formulas that we use kind of, right? So remember, n minus 2 was the number of triangles that were created from our figure. And then we just multiplied that by 180, right? So the sum of interior angles for any polygon, it's the sum of angles equals 180 times n minus 2. Now, we can also look for the measure of each interior angle for a regular polygon. So that would be 1 interior angle equals 180 times n minus 2, all divided by, this should say n, not 2. Now remember, to find each interior angle, this numerator, you should recognize this. This is going to be the entire sum of your interior angles. And then in a regular polygon, we know all angles are going to be the same, so you can just divide that number by the number of sides, and that would give you 1 interior angle. So let's just do 2 practice questions. We're going to figure out the formula that we're going to use. So it says, determine and state the measure in degrees of an interior angle of a regular decagon. So this is where that table is going to come into play. We have to study that table. So if we go back, we can see that in a decagon, the number of sides, or n, is going to be 10. So I know n equals 10, and what are we looking for? We're looking for the measure of an interior angle. So we're looking for 1 interior angle. So right now the formula is this one, because it doesn't give us anything about the sum, right? So I'm rewriting the formula. 1 interior angle equals 180 times n minus 2 over n. That should be n again. Now our n is 10, so we can substitute. So 1 interior angle equals 180 times 10 minus 2 over 10. And if you went ahead and did that in your calculator, you would get that 1 interior angle equals 144 degrees. And remember, see how I rewrote the entire formula out? If you were just using this side of the formula, you might get confused, but that's why I like to write like 1 interior angle equals, and then I'll be able to figure out what to substitute. All right, lastly, we have the sum of interior angles of a regular polygon is 720 degrees. How many sides does the polygon have? So again, they gave us the sum of interior angles, so I know I'm using this formula. So again, sum of angles equals 180 times n minus 2. And let's substitute. So the sum now, I can rewrite as 720 equals 180 times n minus 2. Now there's 2 different ways that you can solve this. You can either distribute the 180 out to both of these terms, or you can divide by 180 right away, which is what I'm going to do here. So we divide by 180 and divide by 180. To get 4 equals n minus 2. Then we need to add 2. So we get 6, or we get our number of sides equals 6. So we have 6 sides, but it might ask us to further classify this, right? This would be a hexagon. So again, make sure you're rewriting the entire formula and substituting the information that they give you so that you know what you're actually solving for.